Today we will be doing 4.1 function notation. So let's start with the definitions. A relation. A relationship is the relationship between two sets of data. So the relationship between two sets of data. So the data we're talking about are X and Y values. So our input will be our X values, and our output will be our Y values. And we will go through this in a moment. It will make a little more sense. So let's just get these down. Now for our parenthesis, for a function is a relationship where there are no repeating X values. Where there are no repeating X values. So that means there will only be one X value. It can't be repeating. So let's go ahead and explore. It says right here, we have these sets of coordinates, and we have our X and Y's. So let's go ahead and label our X and Y's so that way you could kind of see this. So we have our X right here. These are our X's. Actually, for this one, I think I'm just going to label the X values. So in order to find if this is a function, remember in our definition, it says right here, a relationship where there are no repeating X values. So you can only see that X value one time. So let's check. Here are our X values that we denoted. And we have X is 1, 2, 4, and 5. There are no repeating X values here. So we will put yes, this is a function. According to our definition up there, you can only have X one time. It can't repeat. Now let's check in the next set of numbers. Let's label our X's so we can see them. We have 1, 4, 4, 5. If you notice, those 4s are repeating. Therefore, this is not a function. So we will put no for function. So it says, why is the first one a function and the second one not a function? Well, as we noticed, the first one has no repeating values, whereas the second one, so the first function no repeating X values. So let's write that down, no repeating X values. Whereas the second function has repeating X values. So therefore, that's why the first one is a function and the second one is not. I'm going to change this to first. I want to keep them consistent, my labeling. And there we go. So the first function, no repeating X values. The second function has repeating X values. Now let's go ahead and go to number 2. It says, determine whether each relation is a function. So we have the set of numbers, or set of coordinates actually. So let's check our X values and see if they are repeating. We have X, 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 and X. So we have 9, 5, 5, 3, 0. Hope you notice there are those two 5s, which means there are repeating numbers, or repeating X values. Therefore, this is a no. This is not a function. Number 4, we have 0. Well, by the way, these top numbers are our input, our X values, and these bottom numbers, this bottom row, are our Y values, our output. So let's look at our x's. Do we have any repeating numbers? 0, 2, 4, and 6? No, we don't. Therefore, this is a function. Let's look at, oh, sorry, it went out of order. That was number 4. Let's go back to number 3. We have our x values in the top row and our y values in the bottom row. Let's look at the top. Do we see any repeating numbers? 3, 2, 0, -1, -3. No repeating x values, therefore, yes, this is a function. Now, we have this vertical line test. Another way to check if something is a function or not is with the vertical line test. So what is that? It is simply where we draw a vertical line. Draw a vertical line on the graph. On the graph. The line can only touch the graph one time or once. The line can only touch the graph once. And this is, you could draw this vertical line in different parts and make sure that that line only touches the graph once. If it touches more than once, it fails. So we'll put if more than once, then once, it fails. Okay, longer definition, but it's a very easy process. So let's do number 5. We have this line right here. So let's go ahead and do our vertical line test. I'm going to test this point. Oh, we can see it touches the line one time. You can do your vertical line test wherever. If you might say, well, what about over here? Yep, it only touches one time. So is this a function? Well, according to our definition, if the vertical line test, it just has to touch the graph that is being shown one time. And if it can touch it only one time, then yes, it is a function. So we will put passes. And that means it is a function. It passes the VLT, which is vertical line test. Therefore, this is a function. Let's go ahead and do number 6. Okay, we could draw a line here. Oh, good. It passes the vertical line test here. But what about here? Does it pass the vertical line test? No, because we touched 2 points of this function. And yes, a function can consist of 2 different rays or 2 different, that appear to be 2 different lines. So yes, this would definitely not be a function because you hit 2 points at this point that we just denoted right here. So this is a fail. It failed the vertical line test. Therefore, it is not a function. Let's go ahead and go to number 7. Let's draw a line, a vertical line. Does it pass this test? Oh, 1 point there. Yep, we can see anywhere we draw that vertical line, it will definitely pass the vertical line test because it only touches the graph once. So we will put, this is passes vertical line test, and therefore it is a function. Let's do the vertical line test on number 8. If I draw a vertical line here, it touches 2 points. Therefore, this fails the vertical line test, and it is not a function. Now let's go on to the next page, B, function notation. Notice we have this, it reads f of x equals 3x minus 5. So the name of the function here is f of x. So we will write f of x. That's how we read it. F of x is the y value. So let's write y value for a given x value. So in other words, for f of x equals 3x minus 5, it also looks similar to this, y equals 3x minus 5. So let's go ahead and do number 1. F of x equals x squared minus 2x squared. So here's our x squared minus our 2x. So where we see the x, that's where we are going to plug in what we're given. So right here it says f of negative 3. So let's go ahead and take this negative 3, which is, remember, our x right there. So let's go ahead and plug in that negative 3 everywhere we see x. So f of negative 3 equals negative, oh, let's go back here, that should be a negative 3x minus 2, and plug in that negative 3. Now we can go ahead and solve. Negative 3 squared is 9. Negative 2 times negative 3 is a positive 6. Now this equals 15. Let's go ahead and do B. In place of x, we will put a 2. So let's go ahead and put f of 2 equals, well, instead of x squared, we will put 2 squared. So 2, and remember, when you plug in, make sure to use the parentheses. Negative 2 times 2. And then we could go ahead and solve it. For negative 2 times 2 is negative 4, and that equals 0. Again, we are using the, this is the equation that we're plugging everything into, that f of x equals x squared minus 2x. Now f of negative 1. Let's go ahead and plug that into our equation. So our x squared, we will put negative 1 squared minus 2 times negative 1. Now we can solve. Negative 1 squared is 1. Negative 2 times negative 1 is positive 2. Now we have 3. Let's go ahead and do D. F of 3, or actually, f of 3. Mine says f of 1. Let me go ahead and change that. Should be, yours says f of 3, so we will do the 3. So let's go ahead and plug this in here. We have f of 3 equals, we'll do something with that 2 in a minute, but first let's plug in our x value. So 3 squared minus 2 times 3. Now we have 9. Negative 2 times 3 is negative 6, and that equals 3. Now what we're going to do is bring down this 2, right? So we have this 2. We can see that f of 3 now equals 3, right? So what we're going to do is, we have this 2. Now instead of putting f of 3 next to it, the way it has it written, right? It has 2 f of 3. What we're going to do is, instead of putting that f of 3, we are going to replace that f of 3 with the 3 that we just found right there. So now we have 2 times 3. Again, so we took that 2 right there. Let me use a different color. We took this 2, and now what we just found, that f of 3 equals, now we have 2 times 3, and that equals 6. So our answer for this one, for D, would be 6. I'm going to separate these. All right. Now let's go ahead and do E. F of, let's see, yours is f of 5. So let me go ahead and replace my number here. F of 5 divided by 2. So I'm going to change mine to f of 5 divided by 2. Yes, that's what you have. Okay. And let's go ahead and solve this. So in place of our f of x at the top, so we have, let me rewrite it down here so you can see it. F of x equals x squared minus 2x. we are going to replace our f of x with f of 5. We're going to do one step at a time, so we're just going to work in the numerator right now. Let's go ahead and replace our x with 5. So we have 5 squared minus 2 times 5. Now we have 25 minus 10, and that equals 15. Now remember, we have this f of 5, e now equals 15. So we have this f of 5 in the numerator here. Let's go ahead and replace that f of 5 with the 15 that we just found. Now we have 15 over 2. And that is our answer for E, 15 over 2. And we would just leave it as long as we don't have to simplify down. We don't have to change it to an improper fraction, or not improper fraction, but a mixed number. It can stay just like this, an improper fraction. Okay, number 2, use the following graph of f of x to find the value of each. So here we have f of x. Instead of f of x, we have f of 0. So what we will do is, remember, this is our x value, 0 is our x. So we will take that 0, look at that 0 on the graph. So let's find 0 on the graph here. Well, let me see if I have a pointer I can use. Oh, yep, here we go. So let's go ahead and find 0 on the graph, which is right here. Well, actually, it's not on the graph. It's 0 on the coordinate system. But let's go ahead and find where our graph touches. So if we go to x is 0 right here, where is our graph? Can we touch a point on the graph? We sure can. It would be right here at -2. So, and we notice this is our y-axis. So x is 0 right here. But when we go down, this is y equals -2. That's where the graph touches, where x is 0. So y equals -2. Let's go ahead and write that down, because that's where, and when x is 0, y is -2. That's where you will be able to touch the graph, right there, at y equals -2. Let's try that again. B, f of 3. So let's go ahead and find where our x is 3. So let's go where our x is 3, right here. Now, let's go ahead and go down to where our graph is. Y would be equal to -4. So let's go ahead and write y equals -4. Now let's go ahead and do C, f of -5. Remember, -5 is our x value. Let's find -5 on the graph here. There's -5. And where does it touch the graph at? Well, right here, x is -5. When x is -5, y is 0. So let's go ahead and put y equals 0. D, yours is different than mine, so let me go ahead and change this. Not too sure why the notes are different on mine, but that's okay, we can change it. F of 6 equals. So if x is 6, so let's go to 6 on the graph here. What is our y going to be? Well, y is going to be equal to 0 here. So y equals 0. Well, let's change the color to blue. Y equals 0 here. And we can skip the last one on here because you don't have that one. Let's go ahead and go to the next page. The last thing we're going to do is, the last page. On the last page, we're going to do number 3. Use the following graph of f of x to answer the questions. A, so is it a function? Is this graph a function? Let's go ahead and check. Yes, we know it's a function because it passes the vertical line test. So let's go ahead and put yes. Right? We know because it passes the vertical line test. Any point, if we draw a line over here, we know it's only going to touch at one point. And same here. Okay, x-intercepts. what are our x-intercepts? That means where does the graph cross this x-axis? Remember, this is our x-axis right there. Goes all the way across. Whoops. Let me see here. Let me move this. So we see where our x-axis is. Well, we can see the graph crosses right here, crosses the x-axis right here and right here. So these are our x-intercepts. And remember, when we write our intercepts, they have to be in coordinate notation here. So let's go ahead and start with the first one. We see that's at -2, 0. -2, 0. Our next intercept right here is at 4, 0. And our last intercept is at, let me point to it so you can see it. It's right here at 8, 0. So let's go ahead and put that 8, 0. Now, what are our y-intercepts? Let me erase this one. Oh, is that not erasing? There we go. Okay, now what are our y-intercepts? So this is our y-axis. Where does the graph cross the y-axis? Well, we could see it crosses right here. There's our y-intercept, and that point is at 0, -3. 0, -3. D, we have f of 3 equals -2. Well, remember, this 3 is our x, so let's go where x is 3. 1, 2, 3, right there. And what is our y value going to be here? Well, we can see that graph crosses right there at y equals -2. So let's go ahead and put -2. So if you put in 3 for x, you will get a -2 for a y. What happens if we put in 0 for x? What will our y be? Well, let's put in 0 for our x. Here's our 0. What would our y be? It would be right down there at -3. So let's go ahead and put -3. Now, F, you don't have in your notes, so we won't go over. G, you have, instead of an F, you have a G right there. So let's go ahead and do G. If G of x equals 0, then x equals what? So let me go ahead and erase here. Okay, so now let's do, back to this one again. If y equals 0, so there's your y equals 0. I'm sorry, yeah. If your g of x, which is now becomes, instead, because we don't have an input for x, this now reads like y equals 0, since there's nothing to put in for x. So y equals 0 here. Then what are our x values going to be? So we have y is 0. Now it wants to know what our x values are. Well, we can see right here we have this x value right there, this x value, and this x value. We have 3 x values. Our first one will be at -2. Then we have 4, and then we have 8. So let's go ahead and write that down. We have -2. Again, let me change my color. -2, 4, and 8. Those are just our x values. Those aren't our x-intercepts. They're just the x values. And, of course, you don't have h. Number 4, use the following graph of g of x to answer the questions. So if our input of x right here for a is 2, so our x is 2, then what is our y going to be? So we put in our x value of 2. So here's our x value of 2. What is our y going to be? Well, if you notice, we have an open circle here and a closed circle. Let me go ahead and introduce you to that open circle. I noticed we had it on the top as well. Let's go ahead and introduce that open circle concept to you. Let's go back to this top graph at the top for number 3. this open circle right here. So this open circle means the number does not exist. So open circle or open point means does not exist. Now the closed circle on the other end right here, so closed circle means point does exist. And the way that works is we have this open circle means the point does not exist, meaning you can get very close to that point. Like, let's see, that is at 2, 3, 4. That's at 5, where y equals 5. But it means it's not exactly 5. It can be 4.99999, but it doesn't actually touch the 5. Okay, the closed circle, however, it includes that number. So right here, y would equal -2, so it would include that -2. Knowing that, let's go ahead and do number 4. If we put in our 2 for x, so our x is 2, what y value will we get out? So let's see, let's go all the way down to 2. Now, we know we have that open circle, which means does not exist. So we're going to bypass that point because it doesn't even exist. But we have this closed circle, which means it does exist. So y would equal 3 right here. So let's go ahead and put down 3 for our y, which would be 3 right there. Now, what if we put in 0 for x, for b? Let's put in 0 for x. So we put in a 0 here. What y value will we get out? Well, y would equal 1 right there. So let's go put in 1. For c, mine is a little different. So let's change it to look like yours. G of -1. What if we were to put in g of -1? What would our y value be? So let's see, -1. Our y value here would be 0. So remember, this is the whole input and output idea that we wrote about in the very beginning. For D, let me fix mine to look like yours. We have G of 7. If we have, if we input 7 for our x value, 7 for our x value, right here. If we put in 7 for our x value, what will our y value be? Be right here, our y value would be -2. So we have equals -2.